Students, welcome to session 8 on plane stress analysis. This is a demo on stress analysis of a corner bracket using Ansys release 14. This stress analysis of a corner bracket we have already started. We have completed 2 sessions on this. At the end of 2 sessions, it was like this. It was like this. Okay, at the end of the 2 sessions, it was like this. Now, what you have to do now is you have to make. Okay, this is just a geometric model. Okay, this was just a geometric. This has to be converted into finite element model. Okay. Now you see here meshing I take, meshing, and the size controls you take, lines, all lines you take, and you say here element edge length 0.25. As you know here, this is almost 6 inches. 6 inches, if I take element edge length as 0.25, almost 24 elements are created. It is your discrete powers. Okay, as far as possible, you have more number of elements. At least 0.25 you have, so the 24 elements are created. I've told you more the number of elements you create, more accurate the results will be. Okay, anyway, for this problem, you take element edge length as 0.25 and say okay. Okay, then you go for mesh, areas, free, pick this line and say okay. Okay. Okay, now the mesh has been created. That is, it is 0.25, almost from here to here, 24 elements would have been created from here to here and all that. Everything is fine now. Now we have to apply the boundary conditions now. Now see here, this is, we are completed pre-processing. Now we are in the solution phase. Okay, now we have come to the solution phase where we'll load and get the solution. Loads, apply, structural, displacement. You see here, this you remember, because this entire thing has to be constrained. No, there is one easy procedure for constraining all the loads here. If there are more number of loads, it is difficult to sense each and every node. Okay, there is one easy procedure. You just stick to that. Displacement on key points. You take extreme key points. Okay, you take extreme key points 4, 1, 2, 3 at 90 degree. Say okay. And all degrees of freedom 0 you take. Expand displacement to nodes you do. When you do expand displacement to nodes, all these nodes will be constrained. This is an easy procedure of constraining all the nodes, and that means all the nodes, that is UX and UI, that is it should be constrained in both UX and UI. Okay, that is all degrees of freedom must be arrested. This you have done. Okay, once you have constrained here, this cannot move. Now you have to have a tapered load here at the bottom. Okay, tapered load. In that way, see here, pressure on lines you take, you click the bottom half, that is one half you take, say okay. This is 50 to 500 pounds they are given, 50 to 500 pounds they are given. They say apply. Now it has been applied. Then for the second half, okay, here only on the lower half of this pole only you have the tapered load. It is 50 to 500 is done. Now for this you have to do, just say okay. Now we will do 500 to 50. 500 to 50 you do. That means here this is 50 to 500. 500 to 50, this is the tapered load what you have done. Okay, now the constraint has been done. Here it has been arrested. Here you have applied the load. That is in the solution phase. The solution phase gets completed now. Okay, now once you solve this, okay, you see here, now you solve this, solution, solve, current load step you do, it takes time, you have to wait. Solution is done, that message has to come. Okay, solution is done message. If it has come, you've done correctly till now. Okay, if solution is not done, if the solution is done message, if it does not come, you have to recheck the problem. Okay, then now it is okay. Now this also is okay. Okay, then once you do this, we are solution phase is completed. Pre-processing is already completed. Solution phase is also completed. Now we'll go for post-processing phase. General post-processing you go. Then here you see in the plot results, deformed shape, deformed plus undeformed. Just say you see here and see the deformation and all that. And as I've told you, compulsorily plot controls, write meta file, invert white and black. Okay. Okay, invert white and black. That is, this black color will be white, and you save it in the folder. That is, let us say in the desktop. Okay. In desktop, you can save it because these things take. This you give some name. Okay. This is Gurudat deformation plot. Okay, deformation plot. This will be on the desktop. Okay, it is a paint file. Okay, that you can take the printout and give it to the examiner. In the same way, see here, this is deformation plot is over. See here, because of this is constraint, this won't move. Because of the loading here, this is deformed. This is undeformed. That is, this blue is deformed. That's why deformed plus undeformed argument. This is this is actually original one. This and all that. Then the blue, no, this is finally deformed. So much of deformation has taken place, and this is the deformation in inch. Whatever you get, this is in inch because I've done everything modeling in inch. In the same way, plot elements, you go back. Then contour plot you do, nodal solution. Okay, in the same way you do here Vonmises stress also. This is very, very important to us. Okay, this Vonmises stress, if you do, you are getting 2471. Okay, maximum Vonmises somewhere here you have 2471. The stress concentration here is 2471, which is much below the 45,000 psi what I given. Hence, the design is safe. That means for the present loading condition, nothing is going to happen for the structure. That is, for this corner bracket, nothing is going to happen because the stresses developed here is much lower. Okay, that is, this is one thing. Then plot elements you do. Okay, plot elements you do. Then you see here. You see, if you see, then graph this also. See here, before you forget, this also nodal solution. This Vonmises plot now. This Vonmises plot also. Don't forget to have plot controls, write meta file, invert white and black and all that. This saving it in a desktop is again compulsory. This also has to be shown. The examiner has to see what exactly is the maximum Vonmises stresses what you got. Okay, this has to be done. Okay, that means two plot. One is maximum deformation. One is this maximum Vonmises stress. This Vonmises plot also you do this. Then plot elements. Then you do this also. That completes more or less. Then path operations. Define path by nodes. Okay, define path by nodes. You can enlarge it. Okay, define path by nodes. Here, I want the variation of Vonmises stress along this portion of the curve. Okay, along this portion of the curve, what is the variation of the Vonmises stress I want? You say some VG, some name you give. Okay, then say okay, then file, close. Okay, then once you do this, map onto path, you say which one you want to, that is even deformation also along that you can get. but I want stress. Vonmises stress only you take. Okay, SUQV. Okay, say okay. Then plot by plot path item. On graph you do. SUQV only you get. Say okay. Okay, this is how you get. This is a perfect say. This is 2471 and all that. You can clearly see. Initially it is less. As you go, it is higher. Again, it comes down. Again, at one particular point, it is high. Then again, it comes down. This you can clearly see in this plot results. No, this also better. Before I forget, this also under plot controls. Write meta file, invert white and black, and all that. And in that way, you get this file also there. Okay. Okay, this also you say the under Gurdar, under your name. Okay, you give the name, that is variation of Vonmises stress along one half of the fold. Okay, and the top fold. Okay, in that way you finish up this. As you see here, this is under plot results. If you do, you see here initially it is less. After that only it is increasing. You can clearly say that nodal solution. Vonmises stress, if you see here initially it is less, afterwards only it is increasing. Okay, increasing, again decreasing, again increasing, again at the end it is less only. This is what we wanted. This is okay. This is how you show it to the examiner. Say keep saving dB and all that. Okay, okay, save dB and all that. I have told you. Finally, save as .db you should be having. You give your name, analysis of corner bracket, under your name you do it. Okay, .db it should be. Analysis of corner bracket, Gurdat .db you say, and save okay. Okay, once then you can file resume from. If you do resume from, you take the file from that, you are getting back this. Okay, in that way you are able to do one complex problem without any difficulty. Okay, thank you friends. Thank you very much for watching. We'll continue in the next session.